Alrighty. Happy Wednesday again. You doing all right? We made some good progress last week, getting started into some of the variables and expressions right from chapter 2. So I think we got through all the intro to Python last week, so we can get moving into variables and expressions this week. I did some basic stuff here in week 1, looked at some simple arithmetic. Let me zoom in a little bit for you here, sorry. So you can go a little further coming up. So let me start up a new project. We'll leave this one here as is. I'm just going to make a new project for week 2. And we'll make our project. See how well it works for us. Oh, I got to pull up chat over here. There we go. Look at that. That works. Okay. And yeah, we don't need any of that other starter stuff for now. So if you make your project and it's in the right folder, your GitHub client should say, hey, there's new stuff out here. Right? That's how we know we put it in the right spot. If you didn't, it's okay. We can always get it in the right spot later, but it's easier to fix now than to fix later. So if you see your file, great. And again, it's empty. That's fine here. We'll say this is week 2 started. Commits are free. I mean, technically there's like a slight electrical cost because like you have to take the bits and push them out over the network and do all sorts of other things. But like Bitcoin uses tons more electricity than GitHub does for commit. So don't feel bad about it. Like other people are worse than you. It's okay. That's kind of a joke. I'm sorry. All right. Sure. So here's some idea file. If these idea files change, just let them change. We don't care if they change or not. I don't know why I didn't pick them up right away, but that's fine. So we'll commit and push. You want to commit early and often because once you have pushed out to the cloud, github.com has your code. Really, really, really hard to lose your code once github.com has it, which is awesome. Right? We don't want our code to get lost. And if something were to happen to your computer, you'd still have all your code out there available on the cloud, which is nice. So again, you don't have to like interrupt what you're doing, but every time you go and take a break, just go commit and push. So that way you have it out there. What you don't want is to wait until it's done and then commit and push one time. I mean, I guess if you sit down and get it done in half an hour, great, perfectly fine. Commit when you're done. But if you're going to take a break at any point in time or like get some of it done, commit and push that. It's essentially saving it out in the cloud for yourself. That way you can't lose it from there. So it'll make life easier for you. I had some kid fail my class over the summer because he's like, oh, my computer got broken and I didn't commit any of my code. I'm going to go get it repaired. Can I give it to you in 2 days when it gets repaired? I'm like, okay, sure. And then he emails me and says, oh, the repair shop said they're not going to have it done until Friday. Can I give it to you Friday? Like, okay, fine, whatever. The grades are absolutely due Friday. I need it Friday. And then he never contacted me again. And then he emails me last week and says, hey, prof, why did I fail the class? Like, really? This is a surprise to you? Like, you didn't turn in the final project. You didn't tell me anything. I don't know. So commit and push is the story here, right? Any amount of work, just commit and push. It will make life easier for you in the long run. And hopefully nothing happens to your laptops, but you've got that backup here. All right. So moving on then. So looking at, essentially we did the intro to Python last week, so we're gonna move into variables and expressions this week here. So hopefully you all had a chance to sign up for Zybooks here and get a chance to work on it. You don't want to leave it for the last minute. Now, honestly, I don't really care if you do leave it for the last minute, but like it's better for you if you don't, because then you're following along and practicing as we go. Like this is an additional source of practice to talk about the material. I'm going to try and give you examples that are not in Zybooks, so you can hear it one way from me, you can read it and try in Zybooks for another way, we can practice it in lab for another way, and then you can do a project on it for another way. Like you need that repetition to learn something, so don't save it for the end here. Okay? Are you okay so far? All right, so go sign up. I can see the class later, and I'll run the report and see how much everybody did at the end. I have to turn on some of these labs here. Let me make a note of myself here. So turn on labs for chapter 2. Okay. They hide all of them by default. These are a decent amount of work, but it's a pretty good practice for you to go and make sure it matches letter for letter, character for character, space for space. They're pretty sensitive, but they're real good practice. Is that a question?
Yes.
So I think there were labs for chapter 1. Yeah, so there were labs in chapter 1. This is essentially you're like getting used to how Zylabs work. Here, they're pretty basic ones here. So these are just kind of a flavor for getting started. here. Once we get into the other chapters, the labs are, ask you to go do something. And the cool thing is it checks it, right? It will run it with a given input and see if it gets the output that it expects, which is nice. We'll do that automatically for you. So they're named labs. They're separate from the weekly labs we do on Mondays, which are the lab assignments that I'm going to look at and grade. These are auto-graded, so like it takes no effort on my part to say do it. But it's good practice for you folks. So you're going to get a lot of practice writing Python, because really the only way to get good at writing code is by writing code. Okay, and I'll stick to that. All right, so we'll talk about variables and expressions, and then we'll probably save types for next week, which is okay, because there's a lot to the types chapter. There's a lot of moving pieces there with types, and it's okay to have the whole week for it. And then we'll talk about the first individual project when we go. That's project 0. Eventually it'll make sense why I started at 0. It's a programming joke, or not even really a joke, just a programming thing. We'll get there eventually. And then every 2 weeks we'll have another project. So basically there should always be something for you to be working on. And I think you all have lives and other classes. So if you need to get started early and finish it up so you have time to focus on the other classes, start early. If you need to wait until later because you have stuff going on that week for the other classes, wait until later. But please do start before it's like the day before it's due. That's just a recipe for disaster. And I get it. I understand that behavior. If you have a due date that's 2 weeks ahead, you're like, oh, I don't need to start it now. I'm going to wait until later. But if you wait until the day before it's due and then you need help, it's a little bit harder to get a hold of me, especially if more than one of you does that. And I have other classes with other people. We have a similar schedule, which is probably my own fault, but like this sort of cadence of every other week just works out well. So then you're going to be frustrated because I'm going to say I'm busy, I can't help you right now, or there's a line out my door. I wait in line to get some help. So just start early, right? My wife gets upset when I spend too much time on the weekends helping people. I get that you have lives and jobs and things, so I'll do my best. Right? If you need some help on Saturday or Sunday, I'll do what I can. Usually about a 15-minute meeting, or I try not to spend more than that if I can help it, if that's okay with you folks. But I can hop on for a couple minutes here and there on the weekend. The schedule's pretty flexible, so. But plan ahead for me, right? Make my life a little easier, make your life a little easier. Start early. If you have questions, ask them, right? Which is great. And then we do have a syllabus quiz. We didn't have any stuff from chapter 1. It's not really all that interesting of a chapter to give a quiz on. So the syllabus quiz, I graded all of them that were in as of last night before I went to bed, I think. So do 11:59 p.m. tonight. If you haven't had a chance to take it yet, please take that. It's basically free points. And then one of the questions asks you to plan out your schedule. So if you haven't heard yet, hopefully it's not news, but in a typical college class, for every credit that you spend in class, the idea is you spend 2 hours outside of class doing work for the class, whether it's reading or studying or homework or whatever happens to be something for the class. So one of the questions is, hey, go into your calendar and plan out when you're going to spend class time, whether or not you're coming here live, you're going to watch remotely, you're going to watch the YouTube videos, whatever works for you, and then 8 more hours. Right? Put it on your calendar. If you don't need all of it, great. Now you have some open time in your calendar. But if you don't plan for those 8 hours, then it's going to keep getting pushed back and pushed back and pushed back and pushed back again. And then you're going to run into those last minute issues. And then you're going to be upset, and I'm going to be upset. And then you're not going to do well in the projects, and it will go badly. So just plan ahead. Put it in your calendar. Hey, every Tuesday from 3 to 5 p.m., I'm going to spend some time working on the labs, on Xylabs. Just book it. If you get it done early, great. And you don't have to work all the way till 5. But get it in the calendar. Tell me what times you plan for it. And there's free points for doing that. And then you also agree to the academic integrity policy for the course, which when I fail someone this semester, because it has happened every single semester since I started teaching, and I just don't understand it, but it has never not happened. I don't understand why. But when I fail someone, I can show the dean, hey, look, they agreed to the policy. They understood they will fail the class if they cheat. And then they say, okay, good, you did a good job. You have it in your syllabus. You made them agree to it, and they cheated, they fail. That sort of thing. I have had one instance where the committee said the student didn't cheat, and I still disagree with them because they said I didn't tell them they couldn't use previous semester's assignments. I kind of thought that would have been obvious, but apparently if I don't tell you can't use previous work, then they got away with using previous work. So I call that one a technicality. But aside from that one, they've never yet overturned a sanction for academic integrity when I've flagged someone for it. So I'd like to keep that streak going if you don't mind. So don't use last semester's work. Why is that so hard? I don't. Okay, I'm still salty for that one. I apologize, but I'll get over it eventually. All right, so moving into some Python. So PyCharm does know how to work directly with Git, and it has all these Git buttons for pushing and pulling and committing. You have to go and install Git directly, which is not GitHub, the GitHub desktop client. I don't usually bother. Again, I think I mentioned it because I like that the GitHub desktop client is the same no matter if I'm teaching Python or C# or C++ or teaching Java or teaching PHP. Like anything I teach, essentially I can use the GitHub desktop client and it's the same. Right? It just makes my life easier because then all my examples are the exact same way. So if you like all that stuff, great. If you just don't want to be asked about it here, just say don't ask again, just ignore it, and those messages should stop showing up. So either way is perfectly fine. I don't really care one way or the other. It should all work here, but I just prefer the desktop client myself. Okay, so looking at, let's make sure we get all these topics here right. So our different, we did some variables, we did some identifiers and objects, we did some floating point numbers, some basic arithmetic we did a little bit of here, and we did a little bit of input, right? Getting some input from the user. We have to convert their input because that makes a program more interesting, right? The idea that it doesn't just do the first line, the second line, the third line, the fourth line every single time, right? One of those lines waits for the user to type something in. That's a much more interesting project here. So one of the operators you probably aren't familiar with, but if you think back to like third grade math class, you remember before we did precise division, like when we first started with long division, we had remainders. Right? You say, hey, 10 divided by 3 is 3 remainder 1. Right? We can get the remainder in Python, and it's called the modulus operator here. So if I say this would be my remainder is equal, I spelled that right, is equal to 10, and then if I want the remainder here, I use the percent sign here. The percent sign is modulus, or modulo, I think some people say, but modulus. So it's the integer remainder of the division. Why can I not spell today? It's pretty much every day, but some days it's worse than others. So 10 divided by 3, I get the integer remainder here, and I can store it in a remainder. So I can print 10 divided by 3 is, and then I can just throw it right in here, right? I can even do that math. 10 divided by 3. Now, if I just do divided by 3, it's going to give me the correct answer, which is 3.333333333, like infinity, right? So if I want the integer result of division, I can use double divide, or this is integer division here. It's for integer division. So you get the integer result, right? So 10 integer division by 3 is just 3, right? And then with the remainder of, and then that's 10 modulus 3. Oops, that one. And now we have done third grade math class, right? Which is good. Like this is useful. 3 with a remainder of 3, a remainder of 1. I can't read. I think I need more coffee today. This is only my third cup, and it's not been enough because it's noon. I need a little more. Technically, it's not coffee. It's an Americano, but that's just my fancy coffee because that's what the coffee shop has. So these both can be pretty helpful if we want to do, look for specific things, whether or not something is evenly divisible, or it just depends on what problem we're solving. But just know these ones exist. There'll be times when we use them. I will practice some of these in lab next week as well, trying to do some interesting exercises with these here. Okay, so that is modulus and division. The math module. I don't think we looked at any of the cool math stuff, did we? Okay, cool. So we saved that. So Python has all sorts of cool stuff in their library, built right in. So it's math, capital M math? No, lowercase m math. There we go. So lowercase m math dot. And I get access to all sorts of, these are known as built-in functions from the library. So if you want the arc cosine of something, sure. Again, we're not doing any sort of trig. You probably don't need any of that stuff. But if you wanted it, it's built in. Python knows how to do it. Ceiling is really handy. Ceiling will round up. So we'll take a number and round it up to the nearest integer. So if you want to get some specific answer, like with a floating point number, what is 10 divided by 3, and then round it up here, we can do that. So if I were to go, let's see what ask, how about for the int or number of people at party? It's going to be an input of how many people are coming to the party. And then if we're going to do arithmetic with this, right, we need this as an integer value. You can't really do arithmetic with strings. Yes, you can multiply strings, but that's not arithmetic. That's just you get a longer string. That's not really what you want it to do. So I'm going to tell Python, hey, I want all of this as an integer. And I know that's probably not a float because most people don't tell me 3.5 people are coming to a party, right? Yeah, that might be an accurate number here because that last person was a maybe, so maybe we count them as half, but you know, half a person doesn't show up to a party. So the integer value is how many people are coming to the party, and then we'll have a number of slices per person is an int person. Oh my goodness, int of an input of how many slices of pizza does an average person eat? Sure, you tell me how many slices they eat. So depending on who your friends are, if I invite one group of friends, I'm ordering like 4 slices per person. If I invite the other group of friends, I'm ordering 2 slices per person. It just depends on which friends you're inviting, right? We'll ask them how much it is. So I need to figure out how many pizzas I need to order now, right? So I have my total slices needed is going to be my number of people at the party times the number of slices per person, right? Easy enough. Okay, and then we should ask, because depending on where you order pizza from or what size pizza you order, you get a different number of slices, right? Everyone knows Hot and Ready's have 8 slices. Sure, but if you get like an extra large pizza from Jets because they have the best pizza, you're getting more than 8 slices, right? You're getting the extra large deep dish. I think that's a 12-slice pizza, right? If I remember correctly. It's been a little while. Since I've been lactose intolerant, I haven't been eating as much pizza, which is probably a good thing, but it makes me a little sad. So now I'm getting hungry talking about pizza. But we should probably ask them, how many slices come in a pizza, right? Because whatever pizza you're going to be ordering is going to have a different amount of slices, perhaps. So we'll ask them. So we'll have a number of slices per pizza. Then is an int of an input. How many slices come, I don't know, on, in, from? What's the right word here? Slices are in a pizza? In a pizza? That's probably are in a pizza. I don't know, English is hard, and I'm bad at it, I apologize. All right, so now if I find out my total slices needed divided by the number of slices per pizza, will tell me how many pizzas I need, right? So this is pizzas needed is going to be my total slices needed divided by the number of slices per pizza. Because then we can print out, you need to order pizzas needed. Pizzas for the party. Okay, life is good. Let's give it a run. Oh, probably need to not do that math thing yet. So we'll give this one a run. So how many people are coming to our party? 15. All right, that's a party. How many slices does an average person eat? 3. All right, that should put us at 45. And how many slices are in a pizza? 10. Okay, so we need 4.5 pizzas. Now, let's go ahead and call Little Caesars and say we need 4.5 pizzas and see what they say to us. Oh, they don't do that? You can't get half a pizza? Oh, go figure. So maybe we should round it up, right? Round up to the nearest whole number. If I only need 4 pizzas exactly, I don't need to round anything. I have just enough, which is risky for a party. You always want to plan for a little extra for a party because it looks bad as the host if you run out of pizza. Although you can always laugh at your friends and be like, you ate the pizza, you ate more than I expected. Ha ha ha, sorry I ran out. And you're giving them free pizza, so they shouldn't like make fun of you or feel bad about it here. So it's probably okay. But generally you want to have more, and leftover pizza is always good, right? It reheats really well. Generally in the oven, you don't want to reheat your pizza in the microwave. It's subpar at that point. But if you reheat it in the oven, it like maintains a little bit of the crispy crust. It's really good. I'm hungry now. I'm sorry, it's lunchtime. I've done a bad thing. So if we want to round up, then I'll say math.ceil will do the ceiling or round up, right, to the nearest whole number. And now it says, hey, I don't know what a math is. That's okay. So we can click this little button here that says import math. There's a red line. Remember, red lines are bad. It won't run with red lines. So if I try and run it here, 10, I don't know, sure, right, we get errors. So red means it just crashes here. Name math is not defined. Python says, well, I told you can do all these things with math, but I don't really know what math is yet. So one of the things Python does is, because it has so many things in the library, it doesn't by default give you all of them. Now, PyCharm knows about math because it's a very common library, but if we want our program specifically to use it, we need to add this line that says import. So if you don't like typing things like me, you can click on your suggestion here, you want to add import. Now, some of these other options are really bad, right? The suggestions that PyCharm gives you will fix the problem, but not always in the way that you want. So renaming it won't actually fix my problem because I need it to be math. Ignoring it is still going to crash. It's no good here. Marking it all of them as ignored, again, doesn't fix the problem, just ignoring it here. So I want to import math is the best option here. And what it does, up at the top of my code, it adds an import math line. So let me actually move this back down here. So import math, this tells Python, you want the math library in your program. So import is how you tell Python, hey, please go use this thing. And there's all sorts of cool stuff in Python here. Let me find, where is Python even installed? Let me open this in Explorer. I think I have it all in my virtual library, right? Nope, I don't. Maybe it's in C, program files. Hey, my friend, thank you so much for subscribing and donating to the Student Scholarship Fund over here at the College of Engineering and Computer Science at U of M Dearborn. I love the Twitch community. It's so cool. And that was a Prime sub. If you have Amazon Prime, you get a free Prime sub on Twitch, which kicks out $2.50 towards me, which I donate to the scholarship fund. You're welcome to give it to an actual streamer, but if you want to contribute money to the scholarship fund that doesn't cost you anything, it's an option. Just want to put it out there. Python. Oh, come on. Where's my Python installed? It's in like the user's app data, isn't it? C app data. It's local. Goodness. I want to know where Python's installed. One sec. App data local programs. There we go. Local programs, Python. Here we go. So Python 3.10 has all sorts of cool stuff. Where's my math library? Is there not? Where's my math library? These are all the built-in libraries in Python that just come installed with Python. All sorts of cool things you can do. Why am I not finding math? I'll just Google it here. Python math library code. See if we can find it here. And this is the documentation. So docs.python.org/3 for version 3 will tell you all the things, but it doesn't actually give you the code. I wanted the actual code for it. It's somewhere. I'm not remembering exactly where it is here, but you can look if you want to see what all these functions do. You can go look up the documentation website. So ceil, the ceiling, which the technical mathematical definition is the smallest integer greater than or equal to x. Sure, it rounds up. I think it's a little easier to say, but sure. Com, so the number of combinations, if you're doing any sort of statistical stuff, that's super handy. Fabs is something about absolute value with an F, and I don't remember why. They add an F here for absolute value, but it's the fabulous absolute value. I don't know. There's reasons, and I just don't remember what the reasons are. Factorial, floor, all sorts of really cool stuff here in the math library, which is awesome. Exponents, logs of things, powers, take a number to a power. And it even sorts them by type. I love this. All the trig stuff, if you want trig stuff. Angular conversions, hyperbolic functions. Man, I haven't done hyperbolic stuff in a long time. Are you folks, you don't get into this until Calc 2, right? I think Calc 2 is hyperbolic stuff. It's been a little while. Yeah, flashbacks to Calc. Yeah, awesome. It's somewhere in there. But anyway, we're telling it, hey, please add the math library because it doesn't come by default. So now when I have the math library, we can go and do that. So we had 15 people at our party. They ate 3 slices each. We have 10 slices in a pizza. We have to order 5 pizzas for the party. Fantastic. So now we are correctly rounding up to the next value here, how many slices of pizza we need for the party. And it all just kind of works. So maybe I'll do that one up above. I like, this is nice. It has all the values here. Now, if we wanted to, we could also then go add more pizza if we needed to, right? If you wanted to always have extra pizza, we could figure something out like that. Don't worry too much about it. We can get to that later. We don't have all the other comparison stuff we need yet to necessarily add if we haven't rounded, but we're getting there. Okay. Excuse me. So that is some cool stuff in the math module. And now text, right? Doing strings is fantastic, right? As we're working with strings, you can do all sorts of fun stuff with strings. So I can have like a first name is Eric. I can have a last name equals Charneski. And then turns out it's not really arithmetic, but you can have a name is first plus last name, and you can add them together. It's not adding here. It's known as concatenation is our technical term. Just sticks them together. So it will concatenate or attach the two strings end to end and into one new string. So we can do that. Now the problem is when I print Eric Charneski or when I print name now, there's no space there because it just sticks them end to end here. So 10, 10, 10, sure. Right, we get Eric Charneski all one word, which is my username, which is fine, but not super useful for a name. So if I wanted to add a space here, then I could add in the space character, right, and then append in here. So you can append as many strings together as you want. Okay. I think we looked at the multiplying a string, right? It does technically work here. The other fun thing, if we take, let's say our value is 10 divided by 0. We print value here. See what we get. 10, 10, 10, sure. We get, it's a division by 0 division error. That didn't work out. That's unfortunate. How about 10.0? 10, 10, 10. Float division by 0. Ever so slightly different error here because it knows that's a float number. Sure, no problem here. Give it another run. 10, 10, and 10. Still float division by 0. Doesn't like us dividing by 0. That's no good here. Just is going to fail on us. Right? So you got to be careful when we're dealing with input, right? If we are dividing something like number of slices per pizza, if I enter 0, bad stuff's going to happen, right? We'll get into better ways to fix this later. We don't really have super good ways to fix it yet. But if my slices in a pizza 0, right, it's going to fail. Now, this big ugly error here is known as a stack trace. We'll get into that later, what that all means. But what it shows me is the error that crashed and then the line at which crashed it. So it says, hey, at line 20, and I can even click on this, it'll take me right to line 20. Like it's a link, which is really handy here. It says, hey, we tried to divide by 0 because number of slices was 0. Bad stuff happened. Okay. So, and if you're not really sure why it's happening or what's happening here, the other really cool tool we get is the debugger. The debugger is the coolest thing about IDEs or these integrated development environments like PyCharm. You come over to the line numbers here, and in the gray space, notice it's awfully wide here, and they do that for a reason. I can just click on any one of these lines. I can't do it where there's no code, but if there's code at the line, I can click and add a big fat red dot. These are called breakpoints. So what's going to happen is if I run my program in debug mode, it will add a breakpoint, and then sit and wait for me, which is super cool. Because what we get to do then is we get to see the value of all of our variables. So I don't actually want it there. I'm going to put it here at line 18. I want to get the inputs out of the way first. So over at line 18, it will wait for me to tell it, okay, you can do the next thing. So instead of hitting run or right-click run, you go to debug. It's the little bug icon here. I think there's the fun story in chapter 1 about why they're called bugs. Right? Did anyone read chapter 1? They're called bugs because there actually was a bug. Because years ago, you used to not write code on computers. You used to have these physical index cards with holes punched in them. It was nonsense. My father still has a stack of them because he's nostalgic about stuff like that, which I guess is cool, but like, there's literally nothing you can do with it nowadays. Like, no one can go read these things, but sure. So we'll debug it here. We'll find out what's going on. So I get now the console tab and the debugger tab. Okay. So the console tab is where all my prompts are still. So we have 10 people, and 0 slices and a pizza. Now it goes to the debugger tab for me automatically. And it sits and waits. It's about ready to run line 18. It hasn't yet. And then I get to see all of the values of my variables here. So it says, hey, here's your number of people at the party. Here's the number of slices per person. Here's your number of slices per pizza. Here's your remainder. I can see the value 0, right? Which is really cool. I can change it if I want while the program's running, which is really fun. Be like, oh, that was a typo. Let's set it to 10 while that's running behind the scenes. So in debug land, you can do cool stuff like that. But generally what you get to do with this is you can see something didn't get set the way you'd expected it to because something happened in your code that we didn't expect. And we can see, oh, hey, this arithmetic is giving me a different value. So in the Debugger tab, you have a couple different arrows here. You have the first arrow here is like an up and down, is the step over. It says run that line of code. This is the most common one we're going to use. Then later on in the semester, we're going to get into using the step into, and specifically step into my code is the useful one here. Step into is cool, but if it's not my code, it's not all that useful. I'll show you that in a minute. And then step out, again, once we get into writing functions and methods and classes and things, this will be more useful, but pretty much step over is the useful one. So if I run step over, now I'll see total slices needed is 100. So now I can use my step into if I wanted here. Step into will go into this function or this built-in library method here of ceiling. I step in, oh, it didn't do it for me, shoot. I must not have loaded it right. Usually it would take you into that. We could see the code, but it's hidden somewhere. Sorry about that. So if it can't go in, it will just go over essentially. And now I'll see, hey, the pizzas needed is 10 as an integer value, right? 100 divided by 10 is 10. The math checks out. We didn't have to round up or anything. I can step and I can step and step, and I'll see all these variables get set here, which is really cool as we go. And then we get name. So notice some of them are red and some are blue, and the blue one changes. Because the more variables we have, the more things you're going to have in this list here. As they change, they'll turn blue. Right? So name is no longer blue because it's not new here. And now it's about to crash here. You get this, hey, a bad thing happened, a zero division error, bad stuff happened. But we can step through line by line by line by line and watch it run, and it will just sit and wait for us and say, okay, I'm ready when you are. And we tell it, okay, Python, run the next line. Okay, Python, run the next line. And we can have it go slowly to see what's happening, which is really handy. So we can't divide by 0. By 0, it crashes. That's a sad face there. So I'm just going to comment out that line because I don't want it to run here, right? And we don't want print value because that doesn't work either, right? But we can start adding names together, right? That sort of thing. Other fun things we can do with strings, right? We looked at multiplying strings. So if I had a, what do we want here? Just some string, NaN. We'll just do NA here. And then we want some other string. Again, these are terrible variants. I apologize. Is some string times 10. And then I can take, let's say this is my end result. There's going to be some other string plus Batman. Right? And we can print that out here, our end result. And we'll get our fun output here. Batman. That was predictable, I'm sorry. But yeah. Okay. If you're nostalgic for old Batman cartoons or whatever, sure. All right. So you can multiply. Multiplying strings just repeats it. But you can't divide strings, right? Division is no good. So if I try like some new string equals some other string divided by 10, I can't undo this result here. We go run this one. 10, 10, 10, sure. Get unsupported operand types for slash, string and integer. You can't take a string, use a slash with an integer. Doesn't work, right? So these type errors we're going to see a lot if we're doing something that Python can't do. Right? It doesn't work. We saw errors as well if we tried to convert things that weren't numbers. Right? Remember, if we run and say, hey, 10, Python says a value error, invalid literal for int with base 10, 10. We get errors, and just our program crashes. We're sad. Life will be okay. We'll move on. We'll figure out a better way to deal with these later. We kind of have to assume the user will do the right thing for now, because if the user does a bad thing, our program just doesn't work and pukes on it, and that's okay. Maybe the user will get the hint. And some of these errors are like decent, but if you tell most people this message, they're going to have no idea what they did wrong, right? Like most humans, when you tell them invalid literal for int with base 10, 10, they're like, I don't know what I did wrong. I told the computer I wanted 10 people were coming to my party, right? They'd be real confused. So we'll get to giving better messages as we go. Hey, Irene, thanks for joining along online. Sorry I missed your chat. I had to remember, someone was sick and was great. Please don't come if you're sick. If you're sick and you have the energy to join live, go for it. If you're sick and you don't feel like paying attention to class and you're not going to remember it anyway because you're delirious, just go watch the videos. Right? There's not participation points. There's not attendance points. Do what works for you. But some people like still want to try hard when they're sick. They're like, I'm not all that sick. I just have a bad cough and don't want to cough on you. Thank you. I don't want to be coughed on. No one else wants to be coughed on. So yeah, just go for it. Join live if you want. So the only downside is chat only, but generally it works out. It worked for the whole pandemic and no one had any big complaints. I think like one person complained and I said, hey, you could join my Discord voice channel, and they never did. So I don't know why they complained if they didn't want my solution. But some people just like to complain and they don't want solutions. They just want to complain about it. People are weird, but that's sort of how it is. All right. So we did our text here. Let's see. The other fun thing. So in computer land, we talked a little bit about binary last week, right? The bits and ones and zeros, and everything is a 1 and a 0 eventually, and we just put more and more bits together, right? Okay, cool. Sometimes I can't remember what I did last week, so just yell at me if we didn't do that. Each individual character, so each letter in a string, is actually represented as a numeric value. So someone came up with this a long time ago, so we have this thing called Unicode here, or ASCII is another term for it here. I don't remember the big difference here. But every character out there has a numeric value that can be used to store it. So if you look at capital A, it is the number 65. This 40 thing and 1, this is hexadecimal notation. Hexadecimal is base 16. Our regular number system is base 10. Binary is base 2. If you go on and take our 310 class, you can have all sorts of fun with hex. I don't really care too much about hex. But it is the value of 65 for a capital A, which is fun. So I can convert between characters and numeric values if I wanted to. So I can print the value for A is, and then to do that, I use this ord or ordinal function here. So ord gets me the numeric value. It's the numeric value of a character. And we're actually numeric value. We're actually storing numbers here. So to store the word Eric Chanesky, it stores the value for capital E, the value for an R, the value for an I, value for a C, the value for a space, right? It's storing a bunch of numbers all together here, which is kind of fun. We can see what that value is for 65, 10, 10, 10. Oops, we can't actually divide. That's right. Can't divide strings. Sorry, let's go back and run that one. 10, 10, 10. There you go. So value for A is 65. So Python matches. Go figure. It probably knows what it's doing here. We could go the other way around. So the character for number, 60, 5 is A, 6 is B, 7, 8, 9, 69 is, now I want a character or char. They missed the letter A and it upsets me, but CHR for character of 65, 69 here should be the capital E. And then, so if I wanted to print Eric here, we could do this. We could print character 69 plus the character of, let's see, so uppercase and lowercase have different values too. So the lowercase r then is 114, char 114, char of, let's find the I, is 105, 5, and then a C is, let's see, 99. Right? We can essentially get my name out of the numeric values. Not a very interesting exercise, but you can, because they're all stored as numerics. Right? Remember, with the commas, we're getting spaces. If you don't want commas, we can just add concatenations here. I think we can just add them all together here, right? I think I can concatenate. Let's try that. 10, 10, 10. There we go. We get Eric. Right? Life is good. We're able to add them together here. Yeah?
Is there a way to only run like a certain line?
I don't think it will run just the ones you highlight, no. Oh, execute selection in Python console. There we go. I have to allow access for the console. Look at that. That's handy. So the Python console is a little bit different than running the program. I've never tried that before. Thank you for asking. That was cool. I'm very amused now. That's cool. And even like it's automatically like debugging for me. That's really fun. I should do that so I don't have to hit 10, 10, 10. Thank you. You want some bonus points? You can have some bonus points. Here, I have this command here, some bonus points. All right, you get bonus points. They're not actually worth anything though. It's like whose line is it anyway? They're just made up. No, thank you. So we can take numeric values, we can take character values, go back and forth between them, which is fun. But what you can't do is take the ordinal value of an entire string. It's going to get really confused here because it only does one letter at a time. Let me try that. Execute selection. Uh-oh. The zoom there is really funny. Or it expected a character, but a string of length 4 was found. So if you give it one letter, Python knows it's a character. If you give it more than one letter, Python knows it's a string, like a string of characters. So you gotta be a little careful here, which is fun. So other silly things we can do, if you wanted here, we can take our values of our characters and do some sort of math with them. Remember, what is that? Is that a simple cipher? Who's the Greek guy? Caesar? Is that a Caesar cipher? I always think Caesar salad, but you can just translate or shift all your characters by a little bit if you wanted here, right? So if I know these are my values here, right, for my name, or if I wanted to go get the values out here, let's go, let's do E and E, and then we'll do R, I, and C, just in case I didn't know what they were here. R, I, and C. This is probably easier than looking up at the table here. And we go get those values, right? Wow, there's like a weird, there it goes. So 69, 114, 105, 99. Great. So if I wanted to essentially have shifted all of these, I could take all those values and then add 1. Or I can have more variables for it. Right, why not? So my first letter is going to be the ordinal value of E plus 1. And we'll do a second letter, a third letter, and a fourth letter. Second letter, third letter, and a fourth letter. E, R, I, and C. And you know, how about instead of plus 1, how about we ask them here? So we'll have a shift. Will be an int of an input. How many letters should we shift in the cipher? Is it an I or a Y? It's an I, isn't it? Yeah, that's an I. Right, and we'll take that shift, then we'll add the shift to each of these. Right, and then we can print all of these values here then out with character to the first letter, character to the second letter, character to the third letter, character to the fourth letter. We do some conversions after we shift. Let's see, so we need these ones here, right? I love this, I'm so excited. All right, how many letters should we shift in the cipher? Should we just do 1? 1's easy for now. So we get F, S, J, D, right? F comes after E, S comes after R, J comes after I, D comes after C. That looks like it's working correctly here. Right, and if we want to rerun it here, that didn't work. I guess I don't rerun. Let's right click it again. All right, how about -1? Can we go back 1? Why not? Right? E, the letter before E is a D, letter before R is a Q. Right, it seems to be working okay. And then you can get crazy with some of these things here. Let me run that one more time. Run selected. Not okay. They have different zooms. So if we want to zoom like 20 characters, we get nonsense. Not everything looks correct and will print nicely at your console, but lowercase r shifted by 20 is a box. I don't know what that is. So lowercase r would have been 114 plus 20. So 114 plus 20 would be 134, right? 134. I don't know what this one is, whatever this character is here. Start of selected area. It's not an actual character. It just represents something. Sure. So if we wanted, then we can do this arithmetic a little bit better. Now, these are all lowercase letters, so let's go back to uppercase letters because this will make life a little easier for us here. I know that the start is 65 and the end is 90, right? So if I'm less than 65, I should wrap back around to Z. But if I'm more than 90, I should wrap back around to 65, right? Right? If we just want to make this pretend it's like a circle here. So if you go too far back, instead of going below that, just shift back to the Z. Okay, can we do that with some arithmetic? Right, to see if we went, if we're less than 65, we want to go back, or if we're more than 90, we want to go forward. We can do that sort of thing. Now, it's probably easiest then to see. So we'll get the order of the value. Starting at 65 and ending at 90 is a little bit awkward. So if we just take 65 away from all of these, we'll basically be at 0, right? Does that work? So we can say, hey, let's just take that minus 65, puts me at 0. Minus 65 puts me at 0. Minus 65 puts me at 0. Minus 65 puts me at 0. And then we'll add that shift here. Now, let's ignore the backwards for now, because I think it'll make life harder here. So we'll do this starting from 0 to 26. And then what we want to do is I want to see where I should wrap back around. So if I take all of this, right, I want to force some order of operations here. Right, make sure we do that. And then take the modulus of dividing it by 26. Should it be 20? So 0 to 25, right? Is correct. So A would be 0. Yeah, so modulus 26 will say, okay, divide by 26, tell me what the remainder is. If I'm taking 24 divided by 26, I have a remainder of 24, nothing changes. But if I shifted beyond that, and now I'm at like 30, I'm going to take out the number of 26s, and I'll have a remainder of 4. That should put me back at a particular letter. So we'll modulus by 26, and then we'll add 65 back in. Now, oh, sorry, these are yellows. The yellow lines are just suggestions. You don't have to fix them, but the style guidelines say you shouldn't have spaces around your parentheses. It's going to yell at me for all these. So I'm going to go add some parentheses. I don't like them touching, but it yells at me every time, so I'll go fix them. And then we can modulus 26 and add the 65 back in. We could probably do a different modulus if we're at like 90 and then add 65 back in, or I'm sure some of the other math would work here, but it hurts my head right now. So I think this just works out easier in my head, if that's okay with you. I think we could just do the shift modulus 90 and then add 65, but then if we didn't have to modulus, adding 65 is bad, and it's just confusing. So this should make it now a nice circular shift, no matter what the letters are and how far we want to go. So if I want to go 200, well, it's just really how many multiples of 26 was that, right? Was the shift. And it should be fine. So let's give this a try. Let's see if this will work for us here. So we're ignoring the minus because minus gets a little tricky, but let's run that. So how many letters should we shift? Should we do like 50? So shifting by 50, right, is essentially, if we take out 26, that's 24. And a 24 forward is like a back 2. I think that makes sense in my head. Does that make sense? Like if we're shifting 24 forward in the circle, we've just really gone back 2. So C is E back 2. P is R back 2. Right? So I think it's working for us for our little simple cipher here. So I can convert all my letters, add the shift, see how many multiples of 26 I need to take out, add 65 back in so that it starts at 65. Right? So this capital A is 65. So like add a little note here of why we're taking out 65 and adding 65 back in. Is that a question? Remember, that's our modulus. That's the whole number remainder. So I want to divide out all the 26s because I wanted to shift by like 200. Well, I still want just be A to Z. So it's just how many that I end up finally shifting. Because like 27 is the same as 1. Just because you've gone 27, like you've gone all the way around once and then one more is the same as just shifting 1. So we're just saving a little bit of time here. And then the arithmetic works out cleanly for us. So we can convert from letters to our numbers here. Now we aren't handling negatives very well here. We could do some sort of absolute value probably, but that's not exactly the same thing. Like shifting -3 is not the same as shifting forward 3. But right now the math is probably a little trickier that we can solve off the top of my head without some more Python code that we haven't done yet. So this okay? So if we want it here, how about we do that? Let's do math.fabs to make sure whatever they give us then is a positive number. Make sure it's a positive value. Now, -3 isn't going to shift like you'd expect it to, but that's okay. We just, at least it'll work for us here, because otherwise we'll get some funny characters. Let's try it again. So if I run that one here and say let's shift by, didn't I highlight it all? Run. Oh, okay. If I use math and I don't have it highlighted, it's not going to work for me. That's sad. Okay, we found a flaw in our plan here for this now. Okay. Execute that. All right, how many letters? So -3 then should shift by, oh, float can be interpreted as an integer. So we need one more. Did I just do abs? I don't think that works either. Yeah, it's all fabs. So we want that one more time as an integer then. And that's fine. You can take an integer, absolute value it, take an integer again. The problem here is that absolute value is always returning floating point numbers. Sure, we just want an integer. No, okay, that's what happened. My right click didn't work. Run the code in Python. All right, so -3 then should be a +3. E turns to a FGH. Yeah, seems good. So now we can do a simple cipher in Python code. It's a little bit of a pain though to get like your name set up here first, but it works, right? And you just have to figure out how many letters. Later when we talk about strings, we'll look at better ways to do this where you don't have to do it one letter at a time. We just aren't there yet. So if this feels like a lot of work, it is. It's okay. We just don't know all the things yet. We're just having a little bit of fun here. Okay? All right. I think that's text. It's Unicode. Some other fun things in text. These special characters. They're technically copyright content here. Oh, sweet. Thanks, SWK. We can just do abs. That's built in. Let's try that. Can we just say abs? Oh, look at that. Absolute value is built right in. Is that going to work for us? We don't even need math then. I love it. -3. And it gives me an integer. Fantastic. This is even easier than the fabs. Very cool. Thanks, SWK. All right. Positive value. Sure. Special characters. Things that have special meaning in Python. So if I wanted to print Eric Chernesky, we could do that. If you wanted to add in a specific character here, like put my name in quotes here. Notice it got all red on me here because I started a quote, ended a quote, and then started another quote, ended it, and it's all red and upset. You have two options. First, I can just change the quote marks that I use from single quotes to double quotes here. Now, inside of single quotes, I can use the double quotes, and Python's fine with it, right? So I can print out just Eric in quotes here, Chernesky, sure. Or if I wanted single quotes around Eric and Chernesky, again, we could do the opposite. Use the double quotes here to start and end your string, but that's not always an option depending on what sort of text you have and what you're trying to output here, right? So what you can do then is you can use the / character, which is the escape character. The escape character, it tells Python, hey, the next thing that comes is special. So a / quote mark is okay inside of a quoted string here. Because Python says, oh, sure, the next thing is special, and a / quote or apostrophe is actually just that character. So you can use those pretty easily here. Or backslash full quote here, right? Same idea. It's special. It's not going to end the string or anything like that. So perfectly fine to use. Now, those are just quote marks here. But other fun things you can put in here, you can put something like a backslash n is the escape character for a new line. And there's a whole table there. You can go look at iBooks. So this will add a line break in between here. So now I get Eric Charnesky on the next line. Just super cool. And there's actually a space there because there's a space right here. That space in between. So if you want your output to be on multiple lines, you can add in new lines. If you want things to be like tab aligned here, you could print like, here's the menu is going to be, and then we can print a tab for, let's do like $2, and then a tab. Here is coffee, and then we'll print like $2.50, and a tab is espresso. Right? Doing tabs will kind of line things up for you nicely to the next nearest tab. I'm not a big fan of these, but they're fun for certain reasons. Yeah, like it doesn't even fit here because like the amount that it finishes that tab out doesn't even line up right. So I'd have to have two tabs here. But sure, we could line them up with tabs and not have to do our own spaces here to print out a nice looking menu for that sort of thing. So backslash T is for tab, because if I just hit tab, it doesn't do a tab inside my quote here. So tab and shift tab, you can move things in and out. Remember, generally Python gets upset if things are not tabbed properly or spaced properly. Notice it turns red right away. And the error here, if you just kind of hover over it, it should tell me, where is it? There's the message. Unexpected indent. It gets really upset. So Python's very sensitive to your white space here. Well, you can do tabs, you can do new lines, you can put them all in. Now, because the backslash is a special character, meaning this is an escape character, what do you do if you want an actual backslash? Well, you do a backslash backslash, meaning I want a special character. Oh, really actually want the backslash here. If you really want to print one of those here. And then you can get the backslash showing out in your output. All sorts of fun options here. So we get some of those fun tabs, new lines, quotes, backslashes here for those. Other fun options are raw strings. So if you put an R in front of a string, it tells Python, just give me what's in there. So we can print here, and if I put an R in front of the string, we have Eric Charnesky. And now it doesn't do any of these escape characters. It's like, oh, just literally take what's in the string here. So now the backslash gets ignored. Because we've told Python, hey, it's a raw string. Just take it as is. So again, depending on what your text happens to be, what you need to type in, you've got options here. Other fun things with strings that you can do, we can print. So a triple quote. Now I can have multiple lines here. Multiple line, another line, can't spell multiple, another line, 4 lines, wow, right? And we print this one out, it prints out just like it looks, which is kind of fun. And then you can, in here, you can like tab things in or put tabs in over here, or add in some characters, some backslashes here, do them that way. Hey, happy Blur's Day, Y Paladin, thanks for jumping in. So now you get just what you see. So the triple quote is like a similar, you just get exactly what it looks like, but it's a multi-line string, which is nice. So you don't have to have a bunch of different prints here. So if I wanted to print this single menu and not have all these print commands, right, we could do that same thing with the triple quote. Here's my menu, and then tab in $2 for coffee, and I can just kind of visually see that $2.50 tab espresso, right? Single tab wasn't going to cut it with coffee here. It's funny, so tab is actually being converted to spaces though. Notice when I'm highlighting here, it's giving me spaces. So it just converts for me, which is nice. I think we can do menu, and then these ones don't need to be tabbed in, those ones need to be tabbed. And then we run that, we get our nice little menu here. So again, just depending on what you want to do. There's like 3 different ways to do everything in code. So if you like multi-line strings, great. If you like the escape characters, great. Totally up to you. Now I have seen there are some programs that will interpret tabs differently in different number of spaces. So you don't always get 4 necessarily, but that does it. SWK, can we do multi-line prints? Yeah, print the \n EOF. I would have to look and see, not recalling off the top of my head. Sometimes you just gotta try stuff because it's not worth memorizing everything. And so they're multi-line strings, characters, ordinals. Awesome. I think we got through just about everything we needed to here in chapter 2. So I'll turn on those iLabs for you. We'll have a little bit of practice with some of these here. Some of these are fun. And we'll go from there. So next week then, when we come back, we have class on Monday. We'll practice. Why am I getting that error again? That's super weird. Now it loads. Oh, maybe not. That's really pretty. So we can start on chapter 3. We'll have our lab. We can practice stuff from chapter 2 as much as we get out of chapter 3. We'll do the lab on Monday. Should I just download it? There. You can just open a PDF, right? There we go. So the lab on Monday is going to be a little bit funny, but eventually we'll be able to get to the point where the lab will cover the stuff from the week before. Oh, it's after our class, though, isn't it? So it'll probably be like, that's a little ugly. We'll make it work. We'll figure out. Because then I guess Wednesday, Monday will be the new stuff. I might shift some of the stuff around, but I think we're filling into a pretty good format here. So Monday we'll cover types, see how far we get. We might need Wednesday for it as well. We'll talk about Project Zero. Yeah, that'll work out. All right, and we'll just kind of keep that project every other week flow. We'll have labs every week. They're due the week after by 11:59 p.m. Just in case something happens, please don't get into the habit of doing last week's lab during this week. That's not a good habit. That should be the exception, not the rule. Life will go better for you if you're following along, keeping up. So we'll follow along the practices. Honestly, the labs are almost participation points. If you show up and try, I will help make sure you get it done. Right? That's your chance to practice it. I can walk around, I can help you, I can problem solve, I can debug here. When it comes to the projects, I'm still going to help you, but I'm not going to solve it for you. Right? I'll help make sure you know what you're doing, but then you go do the work. With the labs, I'm much more happy to give some help there. And then again, our midterm is a little late in the semester, but that's okay. We'll do a review of the midterm that week. We'll pick back up our last couple topics. We'll start a final project. We'll have all month for that final project, which is the bulk of your score here. And this one should be a little bit of fun. Ideally, we do it in pairs. I'm not going to require the group work. It's not an objective in the class that we do group work, but you'll probably get a better product at the end if you work in pairs with somebody. And it's actually much more fun to work with a person because you can bounce ideas off of each other. You can collaborate a little more. It's really lonely to code all by yourself. So it's just sort of how it is here. So we'll try that throughout. And then we are aiming towards December already. I know it just got to September. We're looking at what's happening throughout. So we got 4 projects, the final project. We got Zybooks to tackle. We got our weekly labs. We got 1 midterm and the final project coming up. It should be a great fall. Okay. Any other thoughts, questions, or concerns? If not, I think we're good. And then I'll see you folks Monday. We'll do class first, and then we'll break, and then we'll have our lab afterwards. Okay? All right, thanks, everybody. Thanks, everybody, for stopping on.